Hello everyone, I am Malshri and today I will be presenting a demo for a project that I've built as part of CS 441, Distributed Objects for Cloud Computing with Professor Mark Rechnick here at UIC. So for my project, I have built a distributed LLM RAG indexer, which is deployed on AWS. And in this video, I will be giving you an overview of the code that I've implemented and also be doing a live demo of its deployment on AWS. So let's get started. As you can see my screen, there are some of the setup for this has been done on AWS, starting with an EC2 instance that I created. So this EC2 instance is to call the Olama server, which is hosted on it. So as part of the initial setup, as you can see my screen, I have installed Olama here, and I'm using the model MXPAI embed for performing the embedding part. So as part of this project, we have input like PDFs that we've been given, and after extracting the text, we are dividing it into different chunks and then doing vector embeddings of it. So for those vector embeddings, I'm using MXPAI. And yeah, so after installing the model, I am just checking whether it is accessible or not. And once I get the endpoints, I have the next steps mentioned here as well. So as you can see, first thing to do is to add the EMR worker security group to the EC2 security group. So this is really important since the EMR cluster will be hosting the MapReduce part of the implementation, wherein it will be performing, the entire uh, extraction, chunking, embedding, and producing Lucene indexes. So that's why it's important to have the security group configured so that the EMR cluster that we create can access the Olama instance, which is hosted on EC2. So this step has already been done by me. The next step to do is to run the MapReduce job on EMR. Okay, so let's go to where our instance is. So apart from EC2, I've also set up the EMR instance as you see here. And while setting this up, some of the things that I'd like to mention. So I have a primary and a core node, which is running on M5 2x large instance. And when I was setting this up, I also had a configuration file for this, wherein I was just configuring that like the memory that each mapper and reducer has is 4 GB, and then out of that the timeout is specified, and this is the JVM heap size, which is 3.2 GB for both the map and reduce tasks. And now let's get started. So we have to add a step here. So as part of a custom jar, let's call it flag indexer. And I'm also using S3 bucket, wherein I have stored my, so this is the config file that I used while setting up my EMR. And in the S3 bucket, I also have my input jar and logs. So this is the jar file that we are using. So this was uploaded after I ran my code, as you can see here. So, I like through SPT assembly, I got the jar file here and then I uploaded it to my S3 bucket. And yeah, so this is referring, and then the arguments that we are going to paste over here are, so rag job is where the main entry point for this code is, and then this is the input file that it is reading. So let me just show that once. So in the input file that I have a pdf.manifest text which has the absolute path of my PDFs. So in the interest of time and for the purpose of this demo, I'm taking a small chunk of the dataset that was provided to us, so which is 10 PDFs. So this PDF manifest gives the absolute path for these files, and if I go to the MSR corpus, this is where it is stored. So yeah, that is the input. And the output here will be in the output final folder. And then this is important. So here we are passing the API that the EMR cluster will be calling, which is hosted in the EC2 instance. So let me just double check that the IP address is correct. So we have to call the private IP of the Olama instance. So let me just copy paste that. Yeah, so this is the step, and once we add the step, this is going to start running. Until then, let me just show you the workflow of my code. So as you can see here, I've divided it into different phases. So phase 0 is more of the setup and configuration for the project, where I've used Scala 3, SBT, and the Olama models that I've used are MXPAI Embed Large and Tiny Llama. Then on to the next phase, which is the input preparation. So the input that we have are the MSR conference papers. We have we have 600 plus papers, and like I mentioned, I'm taking a small subset of that for testing. And then we have the mapper execution. So how this works is the data from the PDF is extracted and chunking is done on it with it's called a sliding window approach, wherein there is a slight overlap between the chunks. And then vector embedding is done via Olama models. And this whole process emits shard IDs and JSON. So on to the next phase. Hadoop groups these shard IDs and the data is sorted. So when the reducer execution starts, it passes the JSON records and builds the leucine indexes. And I've used cosine similarity for this. And with the post-processing of this data, we get a vocabulary CSV or a YAML file, which is basically evaluating the analogies and the similarity between words. And phase 6 was the AWS deployment, wherein we are using S3 buckets for storing the input, logs, output, and the jar file. And we are running Olama on our EC2 instance, and we are also using the RAG API. We are also using EC2 for the RAG API, and on our EMR, we are doing the MapReduce work. And then at the end of it, once it runs successfully, is when we will serve queries to the API. And then on the basis of the queries we give, it will take the top K, like so for my code, I've specified the top 3 chunks that match the query that is given to it. And these chunks are then fed to the model, which then uses the prompt that we gave along with the context that was generated through the chunks. And then it answers and, it generates an answer for us. So this is an overview of the code. And going back to the steps, let's just see if it's running or not. So yeah, it is running. Let's resume this once the step is completed. Thank you. Hey, so as we can see, the job has completed running. Now let's check the logs for that. So the MapReduce job has completed, and let's check the error file. We see that there are no errors. Now we will go check our output. So on our S3 bucket, we see the output final folder, and this is what it's looking like. We have the shards created here. Yeah, this looks good. So now let us go back to our EC2 instance, wherein we will be calling the RAG API. So while the job was running, I installed the Tiny Llama model that we will be using to serve queries, and I also copied the jar file that we had in the S3 bucket. So now, first let's make sure that Ollama is running. Yeah, we see that it's active. Now let's call the API. So here I'm referring the jar file that we have, cs1 server. The jar file that we have, and now this is the part where the API server code is implemented. And this is solely for logging purposes. Let me just make sure that the command is correct. Yeah, this looks good. So let's check if it's running or not. Yeah, it's running. And let's just check the logs. Okay, yeah, that looks good. So we have two endpoints that we can hit. First is the health one, which is just going to give us a health status of the model and the API itself. And then we have the query API. So now let's serve some queries. Now let's call the query endpoint. So this is going to be a post request that we are sending. And the port that we have for this, as you can see, is 8080. And the endpoint is query. Now, when we are calling it, we also have to send headers, which is the content type. And now we will be sending the query. So this would be like the JSON body that we send. So let's ask something like, what is some testing? And let's set a max time. So what this is going to do is it is hitting the query endpoint, and the query that we've sent is what is software testing. So from the indices that are the Lucene indices that are created, it is going to do a matching for the top chunks that match with the query that we've written. So it's going to do, and it's going to fetch the top two matches from it. It's going to include that in the query that is sent to the LLM, and then it has to generate a response. So let's see how much time this takes. And also, so we are doing this on the EC2 instance itself, so that's why we're using localhost. If we had to do it outside of that, so for example, if we were using Postman or something, then instead of localhost, we would simply be replacing that with the EC2 instance's public IP address. Okay, so the query returned some response. So we asked what is software testing? And then it mentions the context provided in MSR paper suggests that collecting and studying snapshot images is similar to working with Marmoset, which would include using a standard version control system such as CVS to store local interactions. And the paper Marmoset, a software repository for real-world software by Edwards, presents the case for requiring students to develop their own test cases during project development. Okay, potentially including defects from pre-existing projects written by instructors. The idea of incorporating these concepts into a software engineering education program could easily be done through Marmoset. However, as noted in the context, there are no quantitative data on how effective these additional tests are, which is why this question is based only on the context provided. So yeah, this is the response we got for what is software testing, and this was my entire demo for the code that I implemented. Thank you.